Okay, this is Algebra 1, Chapter 6, and this chapter is about solving inequalities using addition or subtraction. And this is obviously a night sky that has stars. I don't have it marked on, you can't really tell, I think I maybe wrote over, but the star that shines the brightest in the night sky is Sirius star. It's very far from Earth, and it supposedly takes 9 years for its light to reach us. So by the time we see it, it's 9 years old. And later, in example, we talk about, we use inequalities to describe even greater distances. So this is just another application for solving inequalities. So basically, if you graph an inequality, and inequalities are going to be greater than, less than, greater than or equal to, less than or equal to. Graphing inequality of one variable on a set of points on a number line to represent all solutions of the inequality. So when we find a solution, we can graph that and include in there by the arrow going, continuing out, all the solutions are included in that. Now, as you can see right over here, let me get so here is our graph, and you might notice that our number line graphs, some lines are open zeros, open dots, and some are, like these two down here, are closed dots. So an open dot represents equal to or less than, just like that. A closed dot represents less than, I might have said that opposite of what they were when I drew that, the first two, less than or equal to, greater than or equal to. So that the closed dot includes both, less than, greater than, and equal to. An open dot is just limited to greater than or equal to. And so we can see, if we look up here, a verbal phrase would be all real numbers less than 2, and we would say x is less than 2, and then we would show with an open circle 2, and then all the real numbers that are less than 2. On this example here, we have all real numbers greater than negative 2. X is greater than negative 2. So we have an open circle right there on the negative 2, and we're all the solution would include all the real numbers greater than 2. If we had all real numbers less than or equal to 1, our inequality would be x is less than or equal to 1, and you can see it's a closed dot, and it is going this way. All real numbers greater than or equal to 0, the inequality is x is greater than or equal to 0, closed dot, and the line is going that way. So, I don't know, I just saw this graph and wasn't real sure. I mean, I saw this picture. What we're dealing with in this lesson is this one, and this one, this one, and this one. So, less than or equal to, greater than or equal to, and less than. So, solving inequalities, again, that's those symbols. We were talking about inequality symbols right here. And when you use an expression, verbally, like at least or at most, you're talking about an equality, because you're not saying it is or it isn't. You're saying, well, it's at least this amount, or at most it's this amount. So that's an inequality. And you can use inequalities to represent situations that involve minimum or maximum amounts. Equations have a definite solution. Inequalities have an infinite number of solutions. So an equation is going to have, a specific absolute solution. Inequalities means that there could be a whole bunch. We're basically just saying it's at least this or at most this. And because it's impossible to list it's an infinite number of solutions, a number line graph is used as a way of picturing that and showing that. Okay, so you can see here my stylus stopped working so well. Graph an inequality in one variable. So we're going to write a verbal phrase to describe the inequality and then graph that inequality. So we have here t is greater than 1. So the answer to that verbally is all real numbers greater than 1. And so how you graph it is we have the 1, and we want to, we need to show that it is all those. So the solution continues out. It's an open circle because it doesn't have an equal sign with it. Another example is x is greater than or equal to negative 1. Our verbal answer is all real numbers greater than or equal to 1. We graph that here. We're going, because we have an equal sign here, we are going to graph this, and we will have it going that way. So closed endpoint and the arrow going upwards. Another example is n is less than 0. Verbally, all real numbers less than 0. We have our open circle, open endpoint here because we don't have an equal sign, and our point, is going that way because it's all real numbers less than 0. Now we have y is less than or equal to 4. Verbally, we would say all real numbers less than or equal to 4. We have our endpoint. We have an equal sign, so it's a closed circle, and we are going this way on our number line because it's less than or equal to 4. So the solution of an inequality in one variable is a value of the variable that makes the inequality true. Now, equivalent inequalities would have the same solution. So let's look at x is greater than or equal to 5, and 5 is less than or equal to x. So these mean this. These are the same thing. They mean they're equivalent inequalities. So we've talked about different properties before, but now we're going to talk about the addition subtraction properties of inequalities. And then the next lesson we'll talk about the multiplication property and the division property. And I'm going to be talking about them a lot over the next couple lessons, so you're going to see similar graphics to this. So the addition property of inequalities, if A is less than B, then A plus C is less than B plus C. The subtraction property of inequalities, if A is less than B, then A minus C is less than B minus C. I'm not going to talk about these two here, the multiplication and division, but I just want you to know that there are 4 properties related to addition, subtraction, multiplication, division of inequalities. So here's an example on how to use addition and subtraction to solve inequalities. So first thing you're going to do is solve the inequality and graph the solutions. So our original equation is d minus 5 is greater than negative 7. And what we're going to do, we're going to subtract 5 from both, since negative 5 is being subtracted from the d, we're going to add 5 to both sides to get rid of the 5 so that the d is isolated and it undoes the subtraction. When we do that, we end up with d plus 0 because the 5's cancel each other out there, and plus 5 or negative 7 minus, or negative 7 plus 5, I can't talk, equals negative 2, and so d is greater than negative 2. We'll use an open circle here, and our d is the solutions greater than negative 2, and so it's an open circle with our arrow going to the right. Here's another example. Solving inequalities by adding or subtracting. So here we have x plus 3 is greater than negative 5. We're going to subtract 3 from both sides to isolate the x, and the 3's will cancel each other out, and then we have negative 5 minus 3, and we end up with x is greater than negative 8. And if you graphed that, you would have on your number line, if you had negative 8 here, 0 here, you're going to have open and going that way. One of the things to keep in mind is you can't check all the solutions of an inequality. There's too many of them. So instead, it's good to choose a couple of solutions, substitute them in the original inequality, make sure they make it true, and then choose several numbers that are not solutions and be sure they do not make the original inequality true. So a tip here, to check solutions, choose numbers that make the arithmetic easy. For example, you could check 0 as a value of x. So let's try that. We have with an equation x plus 5 is greater than or equal to 3. I wrote my original inequality here. I have x plus 5. I'm going to subtract 5 from both sides to get rid of the 5, to isolate the x. So when I do x plus 5 minus 5 is greater than or equal to 3 minus 5, I'm using my subtraction property of inequality. And then I am left with x is greater than or equal to negative 2. And then I could graph, so if x is greater than or equal to negative 2, now I can plug in. So I can check my equation. So here was my original equation. X plus 5 is greater than or equal to 3. When I plug in 0, or used 0, I had 0 plus 5 is greater than or equal to 3. That holds true because we'll drop the 0 and we end up with 5 is greater than or equal to 3. And that checks out. And if all my solutions then would be, I went forward just to see something there, would mean that the negative 2 that we had here, we would use that as our starting point on a number line, and so we would have, if that was negative 2, can't really see it, but our number line then, because it's equal to or greater than, would be going, all our solutions would be going that way. So let's look at some checkpoint questions. We're going to use subtraction to solve an inequality. So we have x plus 4 is less than 7. And we subtract negative 4 from both sides, and we end up with x is less than 3. We don't, it's just, it doesn't have an equals with it, so it's an open circle, and it's all the solutions going to the left, all the numbers going to the left. Number 6, it's n plus 6 is greater than or equal to 2. We subtract negative 6 from both sides, and we end up with n is greater than or equal to negative 4. Because we have the equal sign here, we have a closed circle going to, and all the numbers going to the right above the negative 4. And 7 is 5 is greater than a plus 5. We subtract 5 from both sides to isolate the a. We end up with 0 is greater than a, and our solution is a is less than 0. It means the same thing. I just changed the order. And we have an open circle, and the numbers are going to, number line is going to the left. Okay, we can do the same with addition. We can, if we're asked to solve 2 is greater than n minus 4, and then to graph the solution, we're going to write our original inequality. So we have negative 2. I left off my the negative up here, so let me write that in. Oh well, okay, that's not what I wanted. Okay, fix that. So we're going to isolate the n here. We need to get rid of the 4, so we add a positive 4 to both sides. That gives us negative 2 plus 4 is greater than n minus 4 plus 4, and that works out to be 2 is greater than n. We use the addition property of inequality. We have an open circle because we don't have an equals part to this, and all our solutions are to the left of 2 here. And verbal 8, we would say the solution is all real numbers less than 2. And you can check this by plugging in your 2 to the original up here. We could do negative 2 is greater than 2 minus 4, and that would work out. Checkpoint 8 is x minus 5 is greater than or equal to 2. We're going to add 5 to both sides to isolate the x. We end up with x is greater than or equal to 7, and then we have the equals as part of this. So it's going to be a closed circle over the 7, and the solutions will be everything to the right and including 7. On checkpoint 9, we have p minus 1 is less than or greater to negative 4. We add positive 4 to both sides to isolate the p. We end up then is p is less than or equal to negative 3. We have an equal sign, so we have a closed circle, and our solution is all real numbers less than or greater than, less than or equal to 3, negative 3. And actually, I did not draw that correctly. This should be negative 3 and not that right there. I don't know what I was thinking. And it's going to go from the out that way. Sorry about that. And number 10, checkpoint 10, is negative 3 is less than y minus 2. We add 2 to both sides to isolate the y, and we end up with negative 1 is less than y, or I can reorder that to be y is greater than negative 1. And here's my negative 1. And I did the same thing. I got the 2. Clearly I wasn't paying close enough attention. This is the negative 1, and this is incorrect. We need to go this way. So let's say you were asked to write and graph an inequality in one variable. So let's say we have astronomy, and a light year is the distance light travels in a year. 1 light year is about, and look at that huge number. I know that you know that would be 6 trillion. So a light year is 6 trillion miles. The star series is about 8.8 light years, trillion light years from Earth. And it wants you to write an inequality that describes distances to points in space that are farther from Earth than Sirius is. And then graph the inequality. So our solution would be let d be the distance in light years of any point in space farther from Earth than Sirius is. We would write our original inequality in words. So the distance is greater than 8.8 trillion miles. We would translate to math. D is greater than 8.8. Now, I just want to make the point that I go through all these steps so that you can figure out how to solve the word problems and things, so that you know that how to approach that. I know it might seem tedious, but that's what I'm trying to get ingrained, is how you solve these. And so the inequality is going to be an open circle here, and we have d is greater. So I don't know, my program stopped and started again. So the inequality is d is greater than 8.8. There's our 8.8, and it would be an open circle, and all the numbers would be going to the right. So all the real numbers greater than 8.8. Deneb is about 1,600 light years from Earth. So it wants us to write an inequality that describes the distances to points in space that are farther from Earth than Deneb is. So we would say that d is 1,600, and I left off a 0. So d is greater than 1,600. I had to make my own number line because I couldn't find one that big. So here's 1600. We have an open circle, and it's going everything farther than 1600. So your assignment starts on page 326, is to do numbers 19 through 22, 31 through 34, 41 through 55, even, 59, and 60. And this picture here is a picture of melting mercury. And the melting point of mercury is the temperature at which mercury becomes liquid. It's kind of cool looking there. It is the only metal that is liquid at room temperature. So that's kind of interesting fact. So if you want to do a problem with mercury, you can do number 58 2 for extra credit.